A team of conservationists is studying the population of meerkats on a nature reserve. The population is modelled by the differential equation given there, where P is in thousands, and that's the population of the meerkats, and T is the time measured in years since the study began. We're told that when T equals 0, P equals 1, and part A, we need to solve the differential equation and give the answer in that form. So to solve the differential equation, we need to separate the variables. So I am going to take anything that has a P and have that on the left-hand side. So I'm going to move this P times 5 minus P and divide on the other side. Anything that has a dt or t, we'll move that to the right-hand side. The 1 over 15, I'm going to leave that where it is for now. So that's going to give me the 1 over p times 5 minus p dp equals the 1 over 15 dt. Now I want to integrate both sides now. Now this 1 over p times 5 minus p. In order to integrate that, I need to do partial fractions. I need to split that up into two separate fractions. So let's do a bit of work on that. Let's write 1 over p times 5 minus p. And let's write that as a over p plus b over 5 minus p. Let's multiply through, so we'll get a times 5 minus p plus b times 5, b times p. And now we've got our common denominator. Right, now we can see that our denominator is the same for both fractions. So that means the numerator has to be the same for both. So the 1 equals a times 5 minus p plus b times p. I'm now going to say let p equal 0, because that's going to make this term become 0 and allow me to just work out the a. So if p equals 0, I'll get the left-hand side would just be 1, and that's going to be equal to a times 5 minus p. 5 minus 0 is just 5. So a is 1/5. So let's put that back in that equation. Let's now work out b. So I'm now going to let p equal 5, because that's going to make this term become 0. So on the left-hand side, I'll just get 1. And on the right-hand side, I've got the b times p. So the b times 5. So b is 1/5. So we now know what a and b are. Excuse me. Right, so this is going to allow me to take my differential equation and replace the 1 over p times 5 minus p with the 1 over 5 p plus 1 over 5 minus p dp. Now, before I do any integrating, I'm just going to note something at this stage. I've got a 1 over 5 here, I've got a 1 over 5 here, and I've got a 1 over 15 there. So what that's going to allow me to do is I can simplify that by multiplying each term here by 5. So times both sides of this by 5. That's going to make both of these become 1. And on the right hand side, the 1 over 15 times 5 is 1/3. Right, now let's do some integrating. The 1 over p will integrate to be ln p. Then we've got the 1 over 5 minus p. That's going to integrate to be ln 5 minus p, but by the reverse chain rule I'd have to divide by -1 because of the minus p there. So dividing by -1 would actually make this become a minus ln 5 minus p. On the right hand side, the 1/3 will integrate to be 1/3 t, and I've got a plus c as well. Right, let's create a bit of space. Now I'd like to work out that constant of integration, the plus c. Let's figure out what that is. Remember, we were given that when t equals 0, p equals 1. So if we substitute that into this now then, so we'll get ln 1 minus ln 5 minus 1 equals 1/3 times 0 plus c. The ln 1 is just 0. 5 minus 1 is 4. 1/3 times 0 is 0. So we can see that c is -4. Minus ln 4, sorry. Right, what I want to do now is rearrange this equation so it looks like this. So p is the subject. In order for me to make p the subject, I first need to get rid of these logarithms. Now, I can do that with the subtraction law. So, ln p over 5 minus p equals 1/3 t minus ln 4. Next, I can take the exponential of both sides to get rid of this logarithm. The e to the ln cancels out, and so that's going to leave me with p over 5 minus p. And on the right hand side we've got e to the power of 1/3 t minus ln 4. The whole thing is in the power there. It's e to the power of everything. But I could split that exponential up to be e to the 1/3 t times e to the power minus ln 4, which I could simplify further because I've got an e to the power ln there, so that's going to simplify if I can remove the -1, which I can do by taking the -1 and moving it up there to be a power. Now I've got e to the ln, which cancels out, to just leave me with e to the 1/3 t times 4 to the power -1, which is the same thing as a quarter. So just rewriting that line then, I've got the p over 5 minus p equals 1/4 e to the 1/3 t. Right, remember I wanted to make p the subject here. So First thing I'm probably going to do here is get rid of that fraction, get rid of the 1/4. That'll make my life a little bit easier. So let's times both sides by 4 to get rid of the quarter. So times the left-hand side by 4, I'll get 4p over 5 minus p equals e to the 1/3 t. Now let's try and start simplifying the left-hand side a little bit. Let's times both sides by 5 minus p. Let's expand those brackets. Remember that we're trying to make p the subject, so let's move all the p's onto one side. Factorise. And then divide. So that we've got p as the subject. So this is my answer so far. Let's compare that to how we needed to write the answer. What's the same? What's different? Well, they've both got a fraction, but the crucial difference here is that I've got e to the power 1/3 t on the top of my fraction and on the bottom of my fraction. Here we've just got an a on the top, there's no exponential. So that's my clue in that I need to get rid of this e to the power 1/3 t from the numerator. The way I'm going to do that is by dividing by my numerator by e to the power 1/3 t, because that's going to cancel it out and just leave me with the 5, which would be the a that I need. If I do that to the numerator, I have to do it to the denominator as well. And it will be both terms on the denominator that will get divided by the e to the power 1/3 t. The 4 will be divided by it, and the e to the power 1/3 t will also be divided. So the numerator will just be left to be the 5. I will have 4 divided by the e to the 1/3 t, plus the e to the power 1/3 t divided by the e to the power 1/3 t is 1. And all I'm going to do now is I can move this up to be next to the 4 as long as it has a negative power. And this now matches up perfectly with what I needed to show. I needed to show it in this form. So just comparing term by term there, the A is 5, the B is 1, the C is 4. So that's part A of this question. Part B. Hence, so using what I've just done, using this, show that the population cannot exceed 5,000. So no matter how much time passes, no matter how many years have passed, the population of meerkats will not get above 5,000. So no matter how much time passes, I'm thinking, as t tends to infinity, as t becomes a really big number, after 1,000 years or 10,000 years or 1,000,000 years, well, what's going to happen to this e to the power minus 1/3 t? Remember what the e to the power minus t graph would look like. It would look like this. It gets closer and closer and closer towards 0 as t gets bigger and bigger and bigger. So I can say that e to the power minus 1/3 t will tend towards 0. Therefore, the population would tend towards 5 over 4 times 0 is 0 plus 1, which is 5. Remembering that P is measured in thousands, so the population gets closer and closer and closer to 5,000, but it will never actually become 5,000 and certainly never exceed 5,000. So I can say that population will tend towards 5,000 but never exceed. And we're done.